we're supposed to like choose a domain to make this function be 1-to-1. Because if it's 1-to-1, then it has an inverse, right? And so first, a function's 1-to-1 if one input only has one output. That makes it a function. And if every output only corresponds to one input. So if you have x equals 1 and y equals 2, you can't have x equals 3 and y equals 2, because then one output would have two different inputs that corresponds to it. So yeah, one y value would have two different x values. That would make it not 1-to-1. So we checked out the horizontal line test. And this graph is a graph of a function that's not 1-to-1 because you can make a horizontal line and it crosses at two different places on that horizontal line. So what we want to do is we want to restrict the domain. Look, if you just cut it off right here, then any horizontal line you draw is only going to touch once on this graph. So this is from x's, I mean, it looks like the line keeps going. I don't know, maybe not based on the intervals they give us. So it starts at x equals -4 is the smallest value, and it ends at x equals 0. So -4 to 0 is an interval that we could use to restrict the domain to make this function 1-to-1. Or we could do it this way. We could cut off this part and use 0 to 4. So -4 to 0 or 0 to 4. Those are the two intervals of x values in which the function is 1-to-1. We ignore the rest of the function. If you just consider -4 to 0, then this graph is a graph of a 1-to-1 function.